This slide includes the final CAD model on the left, which is the entire product altogether, and on the right of the slide there is the orthographic drawings, which include all of the 5 metal parts with annotations and measurements. The shelf support and rotating arm is a singular piece which can be found 8 times in my product, located 2 under each of the 4 shelves. It is responsible for holding the shelves level as they rotate together from vertical to horizontal while connecting to the aligners. The shelf supporter connecting beam must keep the rotating arms under the shelves in their correct places as they rotate. Meanwhile, the shelf mechanism rest arm holds up the table once it reaches the horizontal alignment. And the main supporter poles are the backbone to the entire product, alongside the horizontal support poles which connect these together in vital places. My design can impact all aspects of life, such as individuals' day-to-day, society as a whole and how it functions, as well as the environmental impact that the product has from being produced to recycled. The individual impact for my product is specifically targeting the demographic of people in tiny or smaller homes. It allows those in smaller spaces to be able to achieve and use full-size shelves or tables with only the amount of space needed for the shelves. Having separate table and shelves can make the individual area crowded and stressful without my product. The negatives to the individual from my product are only minimal. They include the cleaning of the nifty mechanism and not much assistance when being lowered. This could impact typically the older people in general. Societal impacts can reach out to many people, as in this time of living having big, large spaces can be very expensive, so the accessibility for those to a product like this can be enormous. The shopping effect because of it would only need 1 product display instead of 2 entire separate sets of table and shelves. My product can become an overall great product with everyone even without the struggle of space management, as well as the ability to save space if my product went into mass production. The environmental impact from my product would be very minimal if done right. My materials are quite simple as they consist purely of wood and steel. The wood is sourced from mahogany trees mainly located in Cuban forests. The steel, on the other hand, is recycled from previous parts, which is environmentally sustainable. Typically, the steel would come from iron ore, which is naturally mined from the earth. The environmental impact is relatively low, disregarding the fossil fuels used to mine the steel if it is not reused. As there is no power requirement for this product, the environmental impact of the product when in use is nothing. It is just purchased and placed wherever it needs to be without the impact of use. These are the concept sketches from my idea development and thinking stages. They include what are all the possible ideas and concepts I could incorporate into my product. Things including the different materials or wood types for the table and the shelves, as well as shapes of the legs and their style, whether there are any power incorporations I could put into the design, as well as portability, wheels, or connecting a wall or surface to the product. And if the product must be carried, it could dramatically affect the demographic of who can use it. Further research is represented in this next concept sketch page, as it includes the different mechanisms I could include into my product. Mechanisms such as an innovative folding mechanism, coming off a wall, or if it is its own product without the need for a support service, or if it would incorporate any use of storage either in the shelves or somewhere else on the product. The main research of my product is determining which materials and type to use for each dimension of my product. Above is the options for types of wood as well as types of metal. Below are all the possible bolts, screws, washers that I can use to connect everything together, so I must get all of this perfect. Then I have chosen the material. I had to research and choose the best sizes for the shelves, table and frame to function to its best, with the options of metal frame size, length and width for shelves being very important. Here is the start of the experimentation stages for my product, as I had to research how to construct the best prototype and what materials or processes to use. I ended up with this, which worked very well for what I needed to discover for further construction of my product. I used laser cut plastic for the hinges and all the main structural components, as I could use many different sizes and shapes, and I used replication of wood for the shelves. These photos include the almost final shelves and structure for them. I taped them together to properly experiment if they work together and what changes or tweaks I would need to make for them to be perfect. But luckily they were very close to it and already, as I can see in the photos. And here we have on the left the full structure connected together with clamps to ensure there are no flaws in my design and the overall functionality of the product. On the right, it is the same design and product, but testing and how it works with shelves. So I've put the shelves on to see if the folding mechanism would work perfectly and there were no tweaks needed. The primary resources used for this construction project was mahogany wood because of its durability, visual aesthetics, and easiness to work with. The other resource is for the frame, and it is chosen to be the 19mm steel. This is for the great durability, compatibility with the preferred bolts I've chosen, and to be used for the moving parts. And here are the processes used in the construction of the wood boards with the mahogany shelves and the table. It starts off with the measuring, then into the standing and testing, and finally oiling for finishing up the boards. And the steel has slightly more processes which include measuring, cutting, testing, welding, drilling, connecting, and the finishing touches, which is putting it all together. And all of these helped improve the overall quality of construction for my product. As seen in the list here, this production mechanism used many types of emerging technology for the entire process. The internet has allowed me to conduct crucial pieces of research and surveys which have been used to make better decisions and improvements to my product. Sustainable materials such as the naturally sourced mahogany wood and recycled steel, which allowed for minimal environmental impact, as well as the saving of burning fossil fuels and CO2 emissions being burned off into the environment. Customization of furniture from new technology allows me to create and change things in my product in any way I prefer. This was used in things such as the choice of material for my product and the testing of my prototype. Next is the artificial intelligence being used to slightly brainstorm ideas for materials, production processes, and techniques, as well as providing me a base for all of my own work and implementation for my product. Laser cutting technology allows for the creation of different shapes and sizes for the prototype and save precious materials and save them for being used into my final product. Finally, the new improving tools and machinery in the workshop has allowed me to construct and produce a product that is highly innovative and well manufactured overall. The overall effectiveness of my construction so far has been highly productive since the start of construction, and will continue into the finalization of my product. As the table here represents, I have had both some slight and major setbacks during construction, of which include the broken arm on my prototype in the middle of testing, metal not fitting after welding the final structure of my product, holes for the shelf arms not being in the right place, and the shelves not being level after initially connecting everything together. All of these issues were overcome in some type of way with innovative thinking and critical action being put towards them. Whether it was by reprogramming and constructing another prototype arm, re-welding components of my structure to ensure everything was flush, re-drilling all the holes for the shelf arms, or completely remodeling shelves, it was all completed. These two graphs show all of the completion times for my product and the estimation for when things will be completed. As visible in the right graph, construction for the product started way later than I expected it should, but I've managed to make up on most of the time that I gave myself through the major construction segment. The research stage also took longer than initially planned for. I'm expected and certainly able to finish, but must be diligent and persist onwards.